Fishing rods are precision tools disguised as simple sticks, engineered to store energy, transfer motion, and deliver bait or lures with accuracy over long distances. Yet behind every smooth cast is a tightly controlled manufacturing process that turns carbon fibers, resins, and metal components into perfectly balanced instruments. What starts as raw composite material becomes a tuned system of stiffness, flex, sensitivity, and strength, designed to perform under constant stress from casting, fighting fish, and harsh environments. And today on the How Factory, we're going inside modern rod factories to see exactly how fishing rods are made, from carbon blanks to perfect casts. Fishing rods have evolved dramatically over centuries. Early rods were carved from wood or bamboo, relying on natural flexibility and craftsmanship. Bamboo rods dominated for decades because they offered strength and controlled flex, but they were heavy and labor-intensive to make. The real transformation came with fiberglass in the mid-20th century, followed by carbon fiber composites, which allowed rods to become lighter, stronger, more sensitive, and more consistent. Today's rods are the result of materials, science, and industrial precision, not just tradition. The modern process begins with raw materials. Most high-performance fishing rods are made from carbon fiber composites, often called graphite in the fishing industry. These materials arrive as sheets of carbon fiber fabric pre-impregnated with resin known as Prepreg. The Prepreg is stored in temperature-controlled freezers to prevent premature curing. Resin content, fiber orientation, and thickness are all tightly specified because they directly determine how the rod will flex and recover during a cast. Design starts long before manufacturing. Engineers model rod action, fast, medium, or slow, and power ratings based on intended use, such as freshwater finesse fishing or heavy offshore trolling. Computer simulations predict how different carbon layups will bend under load. Once the design is finalized, cutting patterns are created. These patterns dictate how carbon sheets will be wrapped to form the rod blank. The first physical stage is cutting the prepreg. Automated cutting tables slice carbon sheets into precise tapered shapes. Each piece corresponds to a specific section of the rod and is oriented so fibers run in particular directions. Longitudinal fibers provide stiffness and strength, while angled fibers control torsion and prevent twisting. The exact combination of layers is one of the most closely guarded aspects of rod design. Once cut, the carbon pieces are wrapped around steel mandrels. A mandrel is a polished metal rod shaped exactly like the hollow interior of the finished blank. Workers or automated machines roll the prepreg tightly around the mandrel, layer by layer. Tension must be perfect. Too loose and the blank becomes weak or uneven. Too tight and fibers distort. This wrapping stage defines the rod's wall thickness and taper, the backbone of its performance. After wrapping, the uncured blank is wrapped again with shrink tape or cellophane-like film. This outer wrap compresses the carbon layers and forces excess resin outward during curing. The wrapped blanks are then loaded into industrial ovens. Curing temperatures are carefully controlled to activate the resin without damaging fibers. Inside the oven, heat causes the resin to flow, bond fibers together, and harden into a rigid composite structure. Once curing is complete, the blanks are removed and cooled. The shrink tape is stripped away, revealing a rough carbon surface with visible resin lines. The steel mandrel is then extracted from the center. This step requires precision because the blank is thin and strong, but can still be damaged if mishandled. What remains is the raw rod blank, hollow, lightweight, and extremely strong. At this stage, every blank is inspected. Technicians check straightness, wall consistency, and weight. Even small variations can affect casting accuracy and sensitivity. Blanks that don't meet specifications are rejected or repurposed. High-end rods demand extreme consistency, so quality control here is strict. Next comes surface finishing. Some rods retain a raw carbon finish to reduce weight, while others are sanded smooth for cosmetic reasons. Sanding removes excess resin and smooths the surface, but it must be done carefully. Removing too much material weakens the blank. Automated sanding systems and skilled operators balance appearance with structural integrity. Once the blank is finished, it moves to component assembly, The first major component is the handle. Handles are made from cork, EVA foam, carbon composites, or combinations of materials. Cork handles are assembled from individual rings glued together, then shaped on lathes to ergonomic profiles. EVA foam grips are molded or machined for durability and comfort. Handle choice affects weight, vibration transfer, and balance. The handle assembly is bonded to the blank using high-strength epoxy. Alignment is critical because the reel seat, the component that holds the fishing reel, must be perfectly centered. Reel seats are typically made from graphite-reinforced plastic or aluminum, and they're designed to hold reels securely while transmitting vibration from the line to the angler's hand. Once the handle and reel seat are installed, the rod moves to guide placement. Guides are the rings that direct fishing line along the rod. Modern guides are made from stainless steel, titanium, or coated alloys, with ceramic inserts that reduce friction. Guide placement is not arbitrary. Engineers determine spacing and size to distribute load evenly when the rod bends, reducing stress and improving casting efficiency. Technicians mark guide positions along the blank using alignment tools. Guides are temporarily taped in place, then the rod undergoes a static load test. The blank is bent under simulated fishing load to ensure the line follows a smooth curve without sharp angles. Adjustments are made until the guide layout is perfect. Once positioned, guides are permanently wrapped with thread. Thread wrapping is both functional and decorative. High-tension thread binds the guide feet securely to the blank. Automated wrapping machines spin the rod while feeding thread at constant tension, creating clean, uniform wraps. Decorative trim and branding wraps may be added depending on the rod's market. After wrapping, epoxy finish is applied. Liquid epoxy is brushed or dispensed over thread wraps while the rod rotates slowly on drying motors. Rotation prevents sagging and ensures an even coat. The epoxy cures into a glossy, protective shell that locks guides in place and seals the thread against moisture. Multiple coats may be applied for durability. Now comes final balancing and inspection. Finished rods are checked for straightness, guide alignment, weight, and balance point. Balance is critical. A poorly balanced rod causes fatigue and reduces casting accuracy. Some manufacturers add internal weights in the handle to fine-tune balance, especially on longer rods. Performance testing follows. Rods are flex-tested to verify action and power ratings. They're loaded repeatedly to simulate casting and fish fighting. Guides are checked for smoothness, reel seats for clamping force, and handles for bonding strength. Any defects at this stage result in rejection. Once approved, rods receive final branding. Logos, model information, and specifications are applied using decals or printing systems, then sealed with clear coat. The rods are cleaned, polished, and prepared for packaging. Packaging is designed to protect rods from impact and bending during transport. Rods may be placed in fabric sleeves, plastic tubes, or reinforced cartons depending on length and destination. Multi-piece rods are packaged in sections, while one-piece rods require long, rigid packaging to prevent damage. Sustainability is becoming increasingly important in rod manufacturing. Factories work to reduce resin waste, recycle carbon offcuts, and extend product life through better coatings and corrosion-resistant components. While carbon fiber itself is energy-intensive to produce, durability means rods can last for decades if cared for properly. What makes fishing rod manufacturing remarkable is how subtle design choices affect real-world performance. A few grams of material, a slight change in fiber angle, or a small shift in guide placement can completely change how a rod casts and feels. Unlike many industrial products, fishing rods must interact directly with human motion and environmental forces, making precision essential. From frozen sheets of carbon Prepreg to steel mandrels and curing ovens, from carefully shaped handles to perfectly aligned guides and glossy epoxy wraps, the journey of a fishing rod is a blend of materials, science, and craftsmanship hidden behind a simple silhouette. And that is exactly how fishing rods are designed, wrapped, cured, assembled, balanced, tested, and finished. transforming carbon composites into finely tuned tools capable of delivering smooth, accurate casts time after time. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the factories, materials, and machines behind the gear we rely on every day.